Good afternoon, everyone. Delighted to be here. And many thanks, of course, to Arize for the opportunity and the platform to speak about uh, what I think is the latest, greatest, and busiest things in the industry right now. In this talk, I'll be talking about RAG and agentic workflows and my experience with them at Microsoft. We sort of, I'll be talking about this in two parts. One part in the conversational AI space, where we used RAG a lot in order to process some of the enterprise requirements that we had. And another in the security AI space, which Microsoft has kind of doubled down on, as a lot of you know, for the last 3 months in order to respond to breaches. Next slide is not working. Okay. Yeah, so in the conversational AI space, essentially we have a problem because LLMs are essentially non-deterministic. And I like to say in the conversational AI space, it's a lot more forgiving because you have a human speaking to an agent. So any temperature variances in the LLM can actually get absorbed by a human fairly well. So it's a perfect fit for these non-deterministic use cases. And we sort of embrace non-determinism a lot in the conversation AI. I'll quickly give you an intro of the Microsoft Copilot Studio product. It's a SaaS low-code, no-code product for enterprise customers. What it means by that is it's a walk up and use sort of product where you don't really, for enterprise customers, they like to actually walk up and use a product and not have to do a lot of platform level features with it. So that's the general idea of the low-code, no-code product. And then it's a single pane canvas for Copilot authoring, extending, and publishing. So I'll introduce a couple of terminologies here. A lot of you may be familiar already. In the enterprise world, we have C1s and the C2s. So for Microsoft, the C1s are the customers who actually, the big enterprises who actually come to us to use our products and tech stack. And the C2s are their customers who actually use the tech that they actually expose to them. So for example, in the Copilot Studio case, we have a customer service agent scenario where a big customer like HP would walk up to our Copilot Studio single pane experience to create a Copilot. And an earlier version of our product, just prior to GenAI and RAG, had a story where they would drag and drop dialog flow boxes to create the Copilot. Think of it as a Copilot having multiple topics, like a greeting topic when the user first interacts with it, and then maybe a question topic where a certain type of question is asked for the Copilot. And so the C1 author, who's typically like an IT department or a team of engineers in a customer like HP, would come to us, and as a C1 workflow, they will drag and drop boxes to create this dialogue for the Copilot Studio to serve as an incoming query. And then they would specify these trigger phrases for all these dialog boxes. For example, the hello topic could have a trigger phrase called good morning, hi, hello, good evening, or any of these greetings. And then the Copilot Studio, the bot, is then actually configured to respond in a certain way to those type of incoming queries. So we would have a way to match the incoming query intent with a bunch of trigger phrases, and that would actually fire up a response in terms of what needed to be presented to the user. And then the other aspect of this product was the ability to publish on multiple channels. So for example, HP in this case would come to our single pane Copilot authoring experience canvas, create a Copilot, and then they would expose it to their customers on all the channels that they would actually provide customer service on. This could, for example, be HP.com, the website. It could be a 1-800 number that the customers will call for customer service. It could be a Facebook channel. It could be Teams, etc., etc. So that was the other value add of our product, a bot creation experience and then a publishing experience that C1s would actually use. C2s at that point, like me or you, would walk up to HP.com, the website, and start having a conversation with HP's Copilot. For example, one of the questions a C2 could ask would be, does HP printer model XYZ support two-sided printing, right? Now, this query, when it actually goes to the service, it needs to parse this query, figure out what the response should be, and then present the response. So that's sort of the flow that the C1s and C2s go through when they interact with this Copilot Studio product, Microsoft. And you can also imagine the contact center agent experience where the same experience is used for C2s to first start interacting with your customer service agent. But at some point, maybe they reach a dead end and they have to actually escalate to an actual agent in a call center. So this Copilot would be get used in a call center or a contact center scenario as well, where an escalation happened for intents that could not be matched with a preset set of queries. Yeah, quickly moving on to the engineering stack. There was a time before GenAI and RAG where we were fairly applying NLP textbook techniques for processing the intent queries. We actually had DTD generated embeddings, and we had, like I said, triggered phrases where we compute the embedding, and then when an incoming query came in from an HP customer, we would then compute the embeddings and then calculate similarities, cosine similarity to determine whether there was a good intent match. And then we would fire up the topic. Once the intent was recognized, we would fire the right topic in order to actually service the query. And then, of course, there was also slot filling and name identity recognition, where we would figure out what parts of the incoming query we would need to match up with the context that we have so far built up the conversation history, and use those pieces of information or variables to fill up a particular query in order to generate a response. On the services side, we had, of course, as typical, a control plane and a data plane. The control plane was used to service the canvas, the bot building experience largely, and the data plane was the runtime, which actually processed the incoming queries. So the runtime is where we will all do the NLU and the NLG. For example, runtime is where an incoming query from an HP customer would actually hit our runtime, would actually undergo all the NLU in terms of name identity recognition, intent recognition, and the NLG in terms of creating the response and throwing it back at it. So quickly go through a timeline of how this got replaced with RAG in our product. So, I mean, in December 2022, of course, the GenAI evolution happened, and once ChatGPT came out, and I think November 30th, there was a lot of interest, of course. So this is when we started seeing the potential of how this can take over large sections of how we were servicing customer queries. So that started the prototyping stage to some extent, and we started building a prototype that could handle the NLU and the NLG using a promptable large language model at the backend. At the time, GPT 3.0 was out, and we started using that for prompting and generating responses, and we started seeing some cool ways in which we could understand a user's intent and formulate a response based on a corpus that a customer will provide us with. So with that, now we also keep in mind that we are an enterprise business, right? So we have large paying customers who have been paying using our product until then. So we can't really cannibalize the existing legacy products. So we had to find a way to start an entry point basically for a RAG-based stack where we start looking at customer queries and start serving responses. So what we did at the time was we started using a stuff pattern in the RAG stack. So essentially, it was about utilizing the promptability that we had with GPT 3.5, doing a search, a content retrieval, essentially, on the incoming query and the corpus that the customer wanted us to query on, and stuffing it into a prompt in order to actually send it then to OpenAI's GPT 3.5, 3 or 3.5 to start generating the response. Now, this, of course, was fairly, and we also like selected a fallback topic path to expose this to our customers. Remember, we didn't want to make this front end center yet, even though we sort of recognize the potential. So we did this through the fallback topic. So earlier we had a fallback topic when in cases where the intent of the customer's query was not recognized, we would actually have some business logic that the customer actually provided to us that would work to provide the customer response. So in this particular case, we utilized that path and we started seeing a lot of success in terms of the number of queries that could be answered with a RAG stack and a stuff pattern on the fallback path. So, like around the Build conference last year in May, we started seeing a lot of, given the success of our preview release in March, we decided that we were going to make this more central to our product. So we started making this the entry point to our product. So the way a customer would even build a copilot would be to first provide a website or a corpus for the customer's intent, and then we would then enable a RAG stack on top of that in order to start answering pretty much all the queries that a customer would ask. Right, so a customer would now be able to create a copilot based completely off of just a website. So essentially, a very, very friction-free or free almost like in under a minute, a customer could create a copilot and deploy it in under 5 minutes to their website so that the C2s could start interacting with it. And this was the release that we made in May, where we started working off of knowledge sources that were pluggable into this copilot in terms of just the website. So what happened after that was, keep in mind, at the time, the first half of last year, we actually built all this tech in-house in Microsoft. So essentially, there was the RAG stack, there was the processing of the response, and there were a bunch of engineering challenges with the RAG stack itself that were built internally. And at around June of last year, pretty much the open source community exploded with different kinds of offerings on the RAG front. So there were, it was the beginning of RAG agents, and there were a lot of APIs that enabled RAG stack implementations, different sorts with reflection patterns, and also with vector DBs integrated in order to make this whole process much easier. So at the time, also what was happening was there was an explosion in terms of the knowledge pluggability for RAG. So until then, we had used a customer's website to actually serve responses. But then there was an explosion in terms of the different types of data sources that customers wanted us to support. So typically, Microsoft customers wanted Office integration, SharePoint integration, Dataverse integration, OneDrive integration, etc. So once we GA'd this feature in November, we started seeing that there was the next frontier, which was essentially knowledge at the time. So we went ahead and surfaced all these various ways to plug in these data sources to generate a response with our RAG stack. So this should give a pretty cool overview of how our stack worked. And this was, as you can, I mean, like I mentioned, this was built over a period of 9 months, starting from December to maybe Ignite. And essentially, the first step of RAG was query rewriting, the topical action. So this is where a query comes in. So for example, a user could have a conversation where the user is asking about a certain data model That would be the first question. And then the second question could be, does it support color printing? So in order to actually understand that it refers to the printer that was actually mentioned previously, we had to rewrite the customer query in ways that would use the context from the conversation history to make it a one-shot query that we could actually send to GPT-3 and get a response. And the next step, of course, was content retrieval. And so, like I mentioned, we started plugging in with multiple knowledge sources. There was a public data, of course, which was the website on which we would essentially just do a Bing search in order to actually get the chunks required for stuffing into the RAG prompt. A SharePoint pluggable model was also developed because SharePoint had a way to get the chunks themselves. They would actually provide us with the chunks in order to do the RAG. There were a few data sources here that would actually do RAG themselves. So like Azure OpenAI on your data, that was essentially doing RAG internally on Azure with the Azure OpenAI, with the Azure Open, with the OpenAI, Azure OpenAI API on their data. Files were a regular corpus that we support where customers, CVS would be able to upload files. We would actually chunk it and enable search on it. Custom data was another law that we would let customers specify in their bot, or we could actually pull it from other parts of the bot as well. Dataverse, of course, is the data management solution. It gives you a table store for structured data search. And there were also graph connectors for third-party services like Salesforce, ServiceNow, Confluence, etc. And then in a typical RAG fashion, we would do a summarize on this data in order to actually generate the final response to the user. So the user in this case would see something like, okay, this printer, yes, does not support double-sided printing, but hey, you know what? This other printer model also supports double-sided printing. So essentially building in a sales channel with our customer service channel, which are all the things that we started doing. Yeah, I'll go into some of the challenges that we started seeing with our RAG tech stack. And there was also search relevance, which was something that our customers became very sensitive to in terms of not getting relevant results for customer queries. So we employed a whole bunch of NLP techniques in order to figure out if the search chunks that we were getting had the required relevance. And we did this with embedding comparisons, and we did this with other filtering mechanisms that we use to figure out which chunks had to go into the RAG prompt. Error handling was an issue because every time we did not surface a response, we would actually not immediately tell the customer why. So there was a bunch of engineering work that we had to do to figure out one of the various reasons why a answer would not get served up. And that could have been because there was content moderation, maybe a provenance check failed, maybe a search result was actually not relevant enough, etc. So that maybe there was also hallucination. So hallucination and answer rate were two other topics that started becoming challenges because hallucination, as you know, LLMs are prone to. So we had to do a lot of playing around with the temperature setting, a lot of eval set curation, eval set generation, eval runs, and essentially a lot of trial and error and experiments to figure out what combination of settings will make the most sense. So we had a lot of knobs in this. There was the relevance of the search results. There was the config settings on the model itself in terms of temperature. And there were other provenance checks and responsible AI checks that we did in order to figure out, and a whole bunch of NLP techniques that we did to make the response relevant to the user. Another thing that came up frequently was citations. So citations became a challenge because of the vast number of knowledge sources that we supported. Being able to provide the right citation for a particular result was challenging. Since we did a federated search for all these knowledge sources, being able to arrange these citations in the right order, attribute it correctly, was a challenge that we had to devote a lot of engineering resources to. And the other was the knowledge plugin interface. Keep in mind that in the slide earlier, this slide, you can see the variety of the knowledge sources, and we had to design a common interface that we could use for any additional data source that got plugged in. A way to capture the abilities of all these data sources. For example, public data on a big site doesn't really give you any abilities apart from search. But then as you open AI and your data actually comes with a whole RAG stack of its own. So how do you define an interface that can capture the union of all these requirements and not require a lot of engineering changes every time a new knowledge source actually got plugged in? So that was a big challenge that we spent quite a bit of time. I already covered compliance, RAI, and performance checks in terms of figuring out if the URL was a legitimate one. We had a few rules that would figure out if the URLs were well formed, etc. So yeah, so this gives just a couple of screenshots on what our product looks like. So this one is a screenshot of the dataverse table that we supported search on. So this one is a customer account table. It has account rating, city addresses for the city, and a couple of addresses for the business. And what we would do is we would actually so in here, our Copilot then enables RAG on top of this structured data set. So for example, if you ask the question on the basis of this table, right, how many accounts, this box in blue, but if you ask the Copilot the question, how many accounts are located in Redmond, right? So doing a RAG search on this Dataverse table, we will be able to come up with the answer that there are exactly 3 accounts in Redmond. And all the user has done so far is just provided the Copilot with that structured table for the data source. So that was a pretty neat way in which we could essentially have an incoming query get translated to SQL or KQL on the backend, query your data source, and then actually present the answer, an aggregated answer back at the user. This is another example of a query asked on that exact same data set. Can you list their addresses in bullet points? And then again here, as you can probably infer, can you list their addresses in bullet points? The there here needs to get correlated with the previous question where user has actually asked for all the customers who have addresses in Redmond. So now we need to rewrite the query to incorporate that piece of context, and then do another search on the structured table to extract those exact same 3 rows that were aggregated upon the previous query. So there's a lot that's going behind the scenes in terms of querying the data source, using conversational context. All of that comes into one Copilot, and it leads to a delightful customer experience. And this is just to make sure that, just to prove that the previous 2 screenshots were not all smoke and mirrors. I just created a quick GIF that shows a live interaction with this Copilot, where we're actually asking that query, what customers are located in Redmond. So as you can see, we actually get a table of the name and addresses of these customers. And then, for example, if you say, who's our main contact at City Power and Light? Right, as you can see in the previous, City Power and Light was the second row there. So this actually prompts the Copilot to go back to the table, get that exact same row, and pull out the address from there, and then post it to the user. So that's where it's actually looking at a different attribute. The Scott, the person who's, you probably can't see from the distance, but is pulling a different column from that particular row and presenting that as a response to the user. So here I'll start with a slightly different tack. In terms of conversation AI versus how we are using RAG and now Agentic to solve a different class of problems. So the conversation AI is about providing information in the context of a Copilot Studio. We would have a customer walk up, ask questions, and we federate over a huge bunch of knowledge sources to figure out what response would make most sense. So the next iteration of that is where you're having a human interacting with an agent, you're essentially replacing the human with an agent and making the goal of the whole process is task completion, which sort of gives rise to workflows. So here is where two agents conversing with each other can obviously have a more high throughput, or more whole idea, a high throughput of ideas between the two agents. And this allows us to get into agentic workflows, which autonomizes these human workflows. I mean, just 3 more slides. So in security AI, we have an opportunity here to harness rather than embrace, but embrace and also harness the non-determinism that we have with LLMs. And this allows us to do very special things in the area of cybersecurity, because the problem space here has a lot of human workflows. It has data access. And for data access, by the way, Microsoft is sort of uniquely positioned in the space, given that it actually gets data, security data from a lot of verticals in terms of the user identity, office, cloud, etc. And it essentially brings to us the problem of creating tooling on top of this data and providing resolution for these human workflows in a very low latency. So that's generally the description of the problem space for agentic workflows in the cybersecurity space. And here we have a use case for agentic workflow architectures where we have different types of agent designs, different kinds of tooling platforms to play with, and most importantly, an evaluation data set that actually uses human curated content to figure out what common achievements needs to be for a particular task. So on agent design, again, we are a big shout out to AutoGen, an open source framework, which came out of Microsoft research. So here's where we have looked at the user proxy and assistant pattern, user proxy and skills pattern, and the multi-agent group chat. So these are just options that we are looking at to figure out how we can autonomize all the human workflows. And I won't go into too many details because this hasn't shipped yet. It's not a product, but I can talk in terms of analogies, in terms of like any other ML problem, we also encounter bias. And in order to actually address the bias, we have a tool bag with 4 techniques, essentially more prompt engineering, standardizing the tooling, creating a higher and a super type system on top of what, for example, Python or Kusto can actually already provide us. So, and we refer to that as the ontology, where we can actually represent complex types and thus have the agentic workflows make better determinations as they actually go along. And this is where observability also would help a lot in terms of creating the eval sets. And there are, like any other ML problem, we are able to create these eval sets based on fairly narrow shards of the data. For example, if it's a certain type of security incident that we want to look at, we can actually just create an eval set around that particular problem type and figure out how we can build an LLM model and create an agentic design that can use our data access layer to reach resolution for this. Yeah, that was it. In terms of how we sort of customized LLMs and RAGs and agentic workflows to accomplish tasks in the conversational AI space and in the security AI space. Thanks.